Alright, so today I'm going to do a little demonstration. I want to go through and show how board bringup can be done with libhal very easily, or at least with a few steps, after cloning from libhal library. It's going to add a couple of things. We have to rename some stuff, but after that, it shouldn't be too difficult. There's a guide on, let's get to the right location actually. There's a guide on the documentation at libhal.github.io. And you can see here it's on the how-to guide on bare metal armcortex target board bringup. So we're going to go through these steps. So the first step of this is actually to set up the target library. So today we're going to do this for the RP2040. So we're just going to set up this repository, and then we're going to start setting up for building. All right, so first steps first. Let's go through, and if we look at the libhal library directory, some steps here. It basically says every place where you see an arrow, there's going to be some things you need to rename. Usually it's changing it from libhal-library to your actual library name, and maybe some files you need to rename completely. So let's get started with that. So from the top, got the README. I'm actually going to ignore this one because we don't really need to change this. It's just something that you ought to do. So I'm just going to, actually, I'll just call this thing libhal-rp, and for the most part, I will go, oh, I know why. All of this needs to be updated. Everything that says libhal library here needs to be updated to libhal-rp. Okay, so that's all done there. So I'm gonna replace the contents here with this. We're just gonna say libhal libraries for the RP series silicon and microcontrollers. Actually, should probably spell this out a little longer. Raspberry Pi series. We'll keep it like that. Keep it short. We don't need it. I'm not going to put any more for this. Not super helpful. All right, Conan file Pi. Just to take a look at that. So I'm going to change this to RP. Make this. Change all these to RP. Yes, that looks good. Okay, I'm gonna leave the version number as it is, and then the versions for libhal, I forget where we're at. I think we're at 2 or 3 now. So I'm actually just gonna check. Libhal. Yeah, we're at 1.1. So let's put 1.1. Might as well max this out. I think the util's still there. And we're going to be using boost extension or boost unit test for our unit tests and lock it down to this version. All right, so that's pretty much it for this side. Let's go to the CMake. Let's go to datasheets. Well, we can actually do that now. Let's do that now. So let's look up RP2040 datasheet. And what we're going to do, I'm also going to look up user manual. Let's see if you can find it. Maybe they're all the same thing. Oh, I bet they're all the same thing. Yeah, it looks like they have all of the datasheet information and all of the user manual stuff all in the same place. Yes, I think so. Programmer's model, yes, that looks about correct. Cool. So all I need is one item. So I'm just going to save as. I'm going to put this into my Git area. Libhal. Find libhal-rp datasheets and place you in there. Cool. So now we have our datasheet there. We can remove the placeholder, and now we have our datasheets. All right, next step. CMake lists file. Now in the future, besides the datasheets portion, I do want to see if there's a way to automate this, because I feel like there needs to be a way to automate this. GitHub does not have a way after templates to just put in placeholders and replace them, which is unfortunate. I think they're probably working on it. I could bet that they're working on this. But yeah, so let's do this. It's called library RP, at least for now, and then we just call this thing RP here. Targets. I'm actually gonna keep this as library for now. I'll rename it later when I have a real name for this, but I'll need to change it now. I just need to make sure that the link library that I bring in is the libhal-rp, because that's what we renamed in the Conan file.py. And I have to make sure that the package that we find is libhal-rp. The other two can stay as they are, although this needs to be updated to just simply be LPC. Okay. The library currently has that fixed. Just this was cloned a little bit earlier. All right, so next up would be file. I'm going to ignore that for now. Conan file.py. Here I just need to change this out to be RP for now, and everything else can pretty much stay the same. Initializer, I don't think there's actually anything I need to change in these. It's only if I need to change them, but I think for now, they kind of just set up some stuff, get a UART, get a console, get a clock, get a reset. There's nothing I really want to change here, so I'm going to leave those be. Most likely you just need to leave those be. Now, because we're making a target library, this will all completely change because we're not going to be, actually, on that same note, I can remove this because we don't need that anymore. We just need RP. So since this is for a target library, we don't need to actually even include those targets. So in a way, I can probably just make a new folder here, RP 2040, and include these in there. We're not going to try to do too much in here. I'm just going to remove these for now. I'm just going to make these null pointers for now. Actually, I'm sorry. There's actually one thing I could set up. I can get rid of this because that's for LPC. I can remove all of these because we don't have support for these yet. We haven't written any drivers yet, but we do have support for initialize using the Cortex stuff. So I can put null pointer for the console, but the counter does exist. The only thing we have to do is figure out how to kind of get the clock speed, but for that for now, oh yeah, we do need to do that. Yeah, I'll put a null pointer there for now too. We're not actually going to use this stuff when we build. We're just going to kind of like, we just want to kind of make sure everything can build down. And when we step through the code, we can do some other things. That will not be included. The stepping through the code and that kind of stuff will not be included in this demonstration. Just try to get everything 2040 fixed up. All right, so the libhal tweaks the HPP files fixed up. The initializer is now just down to a bare bones. And we're going to get rid of these two because we don't need them. Those things are there just in the event that you just want to like build like a device driver. Okay. All right, so now we have that library. Let's keep it as is. Everything in here, let's turn this into RP 2040 now. So I got a little mixed up here, but yeah. So we came into demos. We left the library folder as it was. Went to targets. For our target library, we made our own target for our target. And then we updated the CMake to, let's get rid of this as well. And I'll just make this 2040 here. Actually, I'll just make that target as it is in this list here. And that, yeah, it's just you had to remove all of the LPC related stuff because we're not programming for that. We're targeting the RP 2040. All right, so that should be everything here. The rest of the stuff can just stay the same because they're all pretty generic. All right, so let's move on. Go to include. Let's change up these directories. I'm just going to do for now, I'm just going to change this directory folder from library to RP, and that's about it. I'll leave the empty library file there. It would be nice to actually change this though. RP and this to RP. Yeah, so now these are no longer, like now they're in our own namespace. Okay. So now test package, let's update that. Test package, RP. So now that just goes to RP, that should pretty much be it. If we go to main, let's actually change this one as well. So RP, we'll use the same library HPP because it's not doing anything. And then we want to change, oh, that's actually fine. And I think that is perfectly fine. Yeah, that looks all good. Cool, so those are the only files you need to change. Your main and your Conan file, and your CMake lists file. Okay. Actually, did I have to change my Conan file? No, I did not. All I had to do is change my main and my CMake list file. Then we go down to tests. We got to go in here and fix that up. So let's go into tests. In here, it's pretty much whatever you need for your library, so that's there, that's good. I'm going to leave the tests name there. I think think this might actually be perfectly fine as it is. Yeah, I think nothing actually has to change. You would go in here and start changing things up to fit your packages, but we don't need to really rename anything here at the moment. And then library, we'll keep that as it is. Yeah, so that's fine. Cool. All right, so I think we're almost done. Yep, and that's it. So that's all the changes we need. We're gonna actually test this out in this folder. This is libhal-rp, and I just want to make sure that I can do coding create dot here and make sure everything works. Okay, so tests, library tests does not exist. Let's change that real quick. All right, this does not exist, but we can do RP, and this should work. Beautiful, that worked. All right, so we can see that we actually have a target declared libhal-rp. We're able to make the whole package. Let me step it through it for you. All right, let's just get to the top, actually. Clear, and let's run it again. So from the top, exporting recipe, grabbed all the different files, license file, HPP file, CPP files for test, and the CMake files, and okay, so it looks good. Using my profile for my computer, bring in all the dependencies, installing the dependencies, running the generator and stuff like that, building the tests, then running them, nothing happened because they don't do anything, then running the test package, still nothing happens because it doesn't do anything, and then we're good. And if you do this on your own, you may want to put in build missing, because if you have any packages that don't automatically build when they are missing, you don't need to include that, but all these are cached for me, so I didn't have to add the extra stuff. Cool. All right, so this is the first part, which is just setting up the library so that it's renamed to the appropriate things. Now we're going to get to the board bring up. Okay, so from here, now look at this guide. This guide tells you what you need to do. In order to build an application as loaded and executed onto a microcontroller, you only need to add the libhal-armcortex dependency, provide the linker scripts for each microcontroller, determine the minimum compiler flags for each controller, and then provide the library component for that microcontroller. I guess you should rename these to those microcontrollers, or for each. Okay, so first steps first, let's go into the requirements and let's add in libhal-armcortex. So the first step is just to go into your, I'm going to close everything up, open back up, go into Conan file pi at the root, and I see to add in this requirements. And that part's done. Yeah, that part's done. Next step, writing the linker scripts. From here, what we want to do is we want to create a folder called linker scripts, and we need to add it to our export list so that it actually gets provided with our package. So I'm going to copy this, scroll up to the top. Here you'll see the export sources where it includes, brings in the includes, brings in the tests, brings in the license. If you're wondering why we don't have a source directory, it's because most of our libraries are header only. We are working to incorporate non-header only libraries for our embedded stuff. That is in the works. Just want to make sure we do it in a way where the pre-built binaries suit most people's needs and aren't going to be bloaty and or too restrictive for people's purposes. Okay, so now we're going to add in linker scripts. And that's good here, but that won't copy anything if it doesn't exist. So let's create a new folder, call it, let me actually close this up a little bit and zoom in. I hope this hasn't been too small for everyone thus far. Okay. New folder, linker scripts. All right. And now to find, so this one gives an example of how to do this for the LPC 4078. I'm going to show you how to do this with the RP 2040. So first thing we have to do is we have to find the flash memory address. Ooh, little typos here. Flash memory address and size, and same thing with RAM. Okay, so let's look into this data sheet and let's see where flash memory starts. So I'm just going to do a little search for it. Okay. So external flash is accessed via the QSPI interface using the execute in place hardware. This allows external flash to be addressed and accessed by the system as though it was internal memory, which is great. That makes our lives a lot easier. There's certain cases where you can't do that, and that makes the linker script a little more confusing, and it makes developing the linker script, the whole process a little bit more complicated. Bus reads to 60 megabyte window starting at this location. So that's our start flash location. So first we're just going to go into our linker scripts, make a new folder, call it rp2040.ld, and here we're actually just going to copy some stuff. So I'm just going to paste this in here for now. I'll just call this thing flash start. Share flash transfer and results return to the master to initiate. Okay. All right. So that is one interesting thing about this particular platform is that it does talk to the flash memory first in order to figure out what its size is. So that's one thing we have to kind of keep in mind is that like the size will be different depending on what they use. So for now, I'm actually just going to lock it down to 60 megabytes. I'm going to assume that we're working with something that is just 16 megabytes, and we can always extend the linker script to support multiple other sizes, as well as also potentially work on ways that we can allow the user to choose what size they want to use for their flash. For now, we want to keep this thing simple because most other microcontrollers we're going to work with are going to have a fixed size, or a lot of them are going to have fixed size flash. Okay, so right above here, it looks like I saw the main memory. Cool. Anything else? This is all the SRAM. Cool. Okay, I think we found our SRAM. There's a total of 256 kilobytes on-chip SRAM. And just so you know, I'm doing this from scratch right now. I've never actually done board bring up for the RP2040, so I'm just going with it. Physically, this is partitioned into 6 banks as this vastly improves memory bandwidth for multiple masters, but software may treat it as a single 264 kilobyte memory region. Cool, so they're all contiguous, right? I think they're all contiguous. Are they all contiguous? Oh, it's split up between different banks. Okay. So like, I think a byte comes out for each, or like a word comes out for each, or something like that. Okay, cool. All right, that's a choice. Nice. All right. So cool. So SRAM starts at this location, and it's this big. It looks like it's this big. Physically partitioned SRAM improves performance by multiple simultaneous. Logically, it's just a single contiguous memory. Beautiful. All right. So now we have. I'm just gonna say for flash size. Let me get this guy back. Flash size is equal to 16 megabytes, and then RAM start is equal to this location, and then RAM size is equal to let's copy this in 264 kilobytes, and that looks pretty good. All right, so I'm gonna save this, and I think we're pretty much done with this portion. I think so. Yeah, I think so. Cool. Alrighty. So that pretty much covers all this section here. This just describes how you would go about finding it inside of a data sheet. So we've already done that part here. All right, so here's some examples. Perfect. So yeah, so I'm just gonna copy and paste this. I'm gonna map it all down. So, okay, it's just the capital K here. So I'm just gonna copy this over to here. Starts at here. I think it's just 16M for this. And then I'm going to copy this. I'm going to make that location for flash. And that's the linker script. That's pretty much done. Right now we're just using the standard ARM Cortex linker script, which just has one flash bank and one RAM bank. And it's pretty much fixed at link time. You just specify these variables here, and then this particular linker script gets pulled in and you can use it. When you include libhal-armcortex, it will automatically make available its linker scripts so that you can utilize them as you need. So that's why we can just include them directly like this. This handles the rest for us. All right, so that's that step. We have to figure out our compiler flags. And the first one is just the processor flag, and the next one is our floating point unit. So let's go into here and let's see what device this thing uses. So I think this is a Cortex M0, right? I think it is, M plus, M0 plus. Now, if you don't know, I'm certain that almost all data sheets pretty much make this stuff present at the top. Usually it's at the top. Find where my cursor is. Like, they'll usually, like, broadcast it as, like, oh, we're low power, and, you know, we do X, Y, and Z. Yeah, it's literally right there. Yeah, so almost all of them will, oh, it's a dual Cortex M0? Interesting. We don't have currently support for dual cores at the moment. So this demonstration is just going to be for a single core, but we are working on adding that feature in the future. All right, so it's Cortex M0 Plus. So if we go over to this list here, you'll see that there is a M CPU Cortex M Plus. So let's add that in. For now, I'm actually just going to go over to my Conan file. I'm just going to paste it down here as a comment because we'll need that for later. Next one's going to be for the floating point unit. Now, I'm certain that, yeah, I did write it out here. If the processor is an Cortex M3 or below, it's soft, so it does not actually have a floating point unit. I'm just going to triple check. Float. Fast floating point library. Yeah, but no floating point unit, I don't think. Okay, so I think they provide some floating point code that makes it fast with their SDK, which is cool. That's awesome. We're just going to be using the, it's just talking about, I think it's just talking about the ARM ABI floating code. Cool. Okay, so that's the code I think will be on the ARM toolchain. I could be wrong here, but again, it's the first time I'm kind of looking at this document here. Looks like it's some type of like library for Pico, a double floating point, so that's cool. For now, we can just know that we're going to be using a soft floating point. Awesome. Okay, great. We have everything we need in order to finish this up. We're almost done. The last step is to create the components for the library. We only have one because we just have the RP2040. So in the package info, you're pretty much going to want to clear it out, and you're going to want to copy this in and basically paste it in. So I'm going to copy this over. And yeah, let's, I'm actually just going to kill this off. I'm going to save that. Need to tab this. Oops, it isn't. Tab this over. Oh boy. Oh, okay. Okay. I think that looks decent. Wow. Okay, okay. One more tab. So I gotta zoom out a little bit. Makes my life a little harder. How it is currently. I can probably just do one more tab. Oh. Okay, let's just tab this whole thing over one more time. And I can move this guy back. Okay, I think that looks good. Okay. All right, so this is a dependency for libhal-LPC. We don't need it. We just need these three items. All right, so we need libhal-libhal, libhal-util, and libhal-armcortex. These aren't the same ones that you'd see in CMake for these different targets. They're just how Conan sees them. So we specified our requirements. Here, I'm just going to delete this because we don't need it. I'm just going to say this is M0P or plus. And here, I'm going to take my commented out stuff. I'm going to paste it in there. I'm going to delete this one because we don't need this extra architecture flag. Let's put these in quotes. Put a comma at the end. And then we're going to paste them here. All right, cool. So that should pretty much do the work we need here. The linker path goes to linker. Oh, that should be linker scripts. So let's make that linker scripts. I'll keep that here. So that should be linker scripts because we can call it linker scripts. This is just basically saying in the package directory, when we take all these files and put them into our package, where can you find those packaged files? And that's going to be in the linker scripts folder. I also need to add the linker scripts folder here too. So that's actually one thing that I do not have inside the guide for LD. So package folder, linker scripts. From the source folder, linker scripts. And I'm just going to put these in new lines so it's a little easier to read. I'm just going to move that there because it doesn't need to be like that. Cool. So destination, package folder, linker scripts folder, and then source is going to be from the linker scripts in our source folder, which is this area here. Okay. All right. So we have linker scripts here. This says the file name is going to be LPC. Let's make it RP. Actually, I can do a control or command D and just change all of these to RP. So that just does that everywhere. Cool. So now we replaced all this with RP. This should stay the same. That's the requirements list. -t libhal / the component name LD. We did rename the folder. Oh, right. One of the things you want to do also is just make a folder called libhal RP and then put all your stuff in there. This just helps with keeping the naming between different things separated from each other. Because technically all linker script names and all chip names should be isolated from each other, like completely like different names for each other. But I can imagine that there could end up being some conflicts, or if someone wants to make their own for their own RP 2040, this just ensures that we keep some things out of the names, out of the directory, keeps name conflicts from happening. So that should be good there. And here, I can get rid of almost all of these. Just do M0 plus, and then call this RP 2040. I think that's everything we need to do for this section here. Yeah, it's the one that we created up here. Okay, all right, zoom out a little bit. Yeah, so that's pretty much all you need to do at this point. And now we have to verify. So first off, let's do a code and create, make sure we haven't messed anything up. All of these can stay the same because we consider the libhal RP property to not have a linker script associated with it and not to have any flags associated with it. So that's useful for doing host tests on a machine and also running unit tests. And yeah. So first I'm going to do a code and create to make sure this works. Okay, looks like it works. I'm going to scroll up a little bit. Oh, warning, directory not found, -L linker scripts. Linker scripts. Is it not linker scripts here? So it looks like it can't find something. So we got to work on that. But it did create the component RP 2040, which is great. That's what we want. All right, so let's go and fix why the linker scripts is not happening here. Linker scripts here. We got the linker scripts here, linker scripts here. Did it copy any of them in? There's a stage right around here where it would have copied everything. I think it copied it. Cool. All right, so let's just look at the package folder. So if you look at this little line here, it tells you where the package is, so we can actually look at it and see what's in there. You have a linker scripts here, and a libhal RP. Warning, directory not found. Was it not found? Is this directory not found? ls, type that in. No, it's there. Very peculiar. I don't understand why it's not saying if it can find it. I'm going to move past this for a sec, see if this comes up when we try to build the whole project. It probably will. But it's weird that it's saying warning directory not found for option this, and also saying it for another thing too. I'm not sure what that's all about. Interesting. Did it say it for the unit tests as well? Don't think so. Okay, let's ignore this for now. Let's go to demos, and here's where the fun part comes in. All right, so we're gonna go into demos, and I'm just going to run conan build dot and see what happens. Okay, all right. So cannot open linker script file libhal RP no such file directory. Okay, so when you're in this situation, the best thing to do is to turn on verbose mode. I'll clear the screen real quick so we can just make sure we can see just what we just saw now. Okay, so here we're going to take a little look at how this whole thing is set up. So I'm just going to copy this whole thing here. This is the command that it was executing. Bring it up in a new tab. I'm going to look for a couple things. So number one, we have this. What is up with the quotes here? The quotes look kind of weird. Let's change let's remove word wrap. Okay, maybe that was not a good idea. Oops, daisy. I don't know why I put sticky scroll on. Let's do word wrap, and let's get rid of sticky scroll. Oh, interesting. Okay, so let's actually remove some of those spaces in there. I think the spaces are causing some conflicts. And that's actually something that, let's get rid of this space here. And then let's get rid of this space that's here. I think that's a problem with the libhal library that shouldn't be there. So I'm gonna go back out. I'm gonna do Conan create dot dot or dot. And okay, so we get only one more of these issues, so that's interesting. I don't know what this one's for, so we'll have to check a little later. So let's go back to demos. And then from here, I'm gonna do Conan build. Just do a normal Conan bids, see what problem we get. And there we go. And it has been built. Cool, that's it. So I will look into and investigate that particular linker problem. But that's pretty much it. That's all you have to do in order to bring up a board. There's a few steps here. I know this is a bit of a longer video, but it's really after you do the library setup and change all the names around, and then once you get that linker script done, you can pretty much build wherever, or you can build whatever you want. Actually, before we go any further, we can actually do a little bit of analysis. So I'm going to look at the actually generated files. So we have we have our disassembly, and we also have our disassembly with all of the code and extra things added in. But I'm just really just going to look at this section here. What I'm really just looking for is that the flash address is the first thing we see here. Well, usually it's the first thing we see here. So this address here, and this is like the symbol for this location. The first item in this is actually the interrupt vector table. If you know what that is, it is for ARM, Cortex M or Cortex M devices, it's a certain format. We want to see that the first item here is going to be the top of stack. Basically, it's going to be the end of your RAM. And because we looked over here and the RAM is at this location, then it's plus 264 kilobytes. That's what this should pretty much indicate. And that looks about correct. The next item here is just where the reset handle is going to be. Although it never usually goes directly there. Yeah, so I'm not going to worry about that too much. But yeah, so this looks perfectly fine. We have those addresses. These look correct. And since we use the built-in CRT0 implementation, which is the built-in startup routine that ARM Cortex provides for developers, it'll make sure it gets to it does all the appropriate things before it calls main. Okay, so that's pretty much it for how you do board bring up for with libhal for an arbitrary chip. Hope you guys enjoyed that, and I hope you guys feel encouraged to start making your own, bringing up your own devices. If you need any help, you can always go to libhal.github.io. If you are still kind of confused, you can always go to our GitHub, which you can not GitHub, sorry. You can go to our Discord. Here, click on this link, and it should bring you to our Discord, and you can ask questions on our Discord. So thank you very much for coming along, and I hope to see you later.